We're good.
Perfect. So good afternoon, everybody. This is Todd Lawrence, speaking to you from highway in the mountains up in Kirkwood, California, where I've been snowed in and sheltering in place for the last couple of weeks. But it's nice to have the opportunity to, there we go, I'm even larger on my own screen. It's nice to have the opportunity to talk to all of you and to spend the next hour or so talking about something near and dear to my own heart, which is big data. The presentation that I have prepared for you, and I'm going to go ahead and share my screen right now, is called, all right, do you have the full screen view of it now? Perfect. I need to unblock, there we go. So we're going to talk about disruptive technologies, open source commercial models, and the arrival of the cloud, lessons from the big data era. So again, Todd Lawrence, I was a UCLA full-time MBA student. I graduated in 1992, spent the first 10 years of my professional career in operations and manufacturing, and then just happened to find myself in sales and have been doing software sales ever since. So I will say before I start that, I'll make two comments. First of all, I'm very excited about the opportunity to present today, because just preparing this presentation allowed me to get in touch with a lot of old friends and colleagues from the big data years that we're about to speak to. And it was personally very enjoyable for me to reconnect with a bunch of former colleagues. So thank you for the opportunity to do that. Also, I would love to be able to make this as interactive as possible. So Dorina, if you can help me to monitor the questions that will come in via chat, and if I could ask everyone to ask their questions via chat, Dorina, you can then stop me and moderate questions on the fly, or decide to hold them till the end based on whatever the topic is that someone asks about. Is that gonna work?
Yeah, that's fine.
Perfect. All right, so let's go ahead and get started. There we go. So here's the agenda. We have an hour and a half. This could easily be a 3-hour discussion, but I'll cover it relatively quickly. We'll talk about the origin story for a technology called Hadoop, which was the original big data platform. We'll talk about how the open source development model gave rise to what we affectionately refer to as the Hadoop Zoo. We'll talk about competing with free and the particular challenges of open source commercial models. We'll then talk about the rise of the cloud and how it disrupted everything in the software world, including the big data world in particular. Then I'll end with a little discussion of what analytics at scale looks like today. And we'll talk about some of the lessons learned from the experience that I had through the big data years, and I'll help to apply those to building a software company today, since I imagine many of the people on this call are thinking about either joining a startup or potentially even starting your own software company. So let's start with Hadoop, the big data origin story. I'll come back to this particular photo of a stuffed elephant in just a moment. But before we get started with the history, I've done many presentations on the topic of Hadoop, and I always like to start the presentation by baselining everyone's familiarity with the technology. And I would usually ask the audience if anyone could give me a 20-second description of what is Hadoop. And this was my version of a quick elevator description of Hadoop. Hadoop is open source software that was designed to store, process, and analyze very, very large data sets stored as raw files, meaning in whatever native file or bit level formats they were created in. And the data could be what we call structured data, which think of database tables and Excel spreadsheets where data is organized by columns and stored in rows. It could be completely unstructured data, where you can imagine images or streaming video or geospatial data, or anything in between. So that's the simplest description of this technology called Hadoop. Let's talk about it from the standpoint of its origin. The original gangster big data problem when Hadoop was born was this question that was essentially brand new to everybody, which was how to make the internet searchable. So if you remember back in the late 90s, Google was founded around a search technology called page ranking. And everybody, all the different internet portals of the day were trying to come up with ways to understand what was going on in the internet. There were new web pages coming up every single night. There were people searching during the day, and there were companies trying to monetize all of this information. But the context for these challenges was very different than what it is today. From an IT perspective, the cloud didn't exist. So everyone was storing and processing information on servers. Very expensive proprietary hardware and software was being used, and they were all doing it in data centers. So you had to manage all of this hardware and software yourself if you were in the IT world. And people were only used to working with structured data in databases. They didn't understand, because a lot of the devices that created these unstructured data sources didn't even exist. So that's the context. And one of the people working on this problem was a gentleman named Doug Cutting, who worked at an internet portal named Excite. He was essentially a software engineer tasked with Excite's version of how do you make the internet searchable. And he started in the year 2000 by creating this open source software project called Lucene, just to do text search, right? Because back then, even searching through large amounts of text was really important. Doug Cutting had a little bit of experience in the open source world, and so his bias was always towards leveraging the power of other developers within the open source community. So he created this project in 2000 called Lucene that turns out to be pretty good technology. It still is at the core of a lot of web searching technology today, just for doing text searches. That morphed into another project that he and another graduate student friend of his, Mike Caffarella, created in 2003 called Nutch, or Apache Nutch more precisely. That was one of the first web crawlers that would go up and essentially crawl the internet at night, catalog all sorts of new web pages, and then use Lucene to analyze the code in the HTML and figure out what links were there and how other people could then be able to search all of these constantly new web pages that were appearing daily. It was an extraordinary problem, and a lot of people were working on trying to solve it, but Doug Cutting and Mike Caffarella ran into very quickly the limitations of doing this work on a single computer server. Both a limitation in how much information they could store on one server and a limitation in their ability to run the very basic analytics on that data to try and create indexes for searches. So this is the context that Hadoop was born. When they hit these limitations, Doug Cutting, just at the time, happened to read two white papers published by Google that talked about how Google had solved these problems, but of course Google did it in a very proprietary manner, and they didn't release the code, but they did describe it in enough detail that Doug Cutting was able to replicate a different version of their solution, and he created it in an open source way, and he called the storage part of his solution the Hadoop distributed file system, and the compute or the analytics part he called MapReduce. So those were the first two components of what has become this very large analytical platform called Hadoop. Then, so this happened in the 2003 to 2005 or 6 era. By 2007, this open source software platform called Hadoop had just exploded, and all the big internet companies that were emerging at the time were using Hadoop, and all of them had communities of software developers that were operating in this open source world, that were working, they were collaborating across corporate boundaries, creating this common set of code in the open source world, managing it as an open source project, and the pace of innovation was just extraordinary. In 2008, a company, Cloudera, was formed. This is the company that I worked for almost 7 years or so. That was the first company to release what we call the commercial distribution of Hadoop, which means taking the open source components of Hadoop, packaging it into a software distribution that was managed, tested, bug fixed, and everything by one company, Cloudera. And that began the beginnings of the commercial era for this open source project called Hadoop. Subsequently, two competitors emerged. MapR launched in 2009, and then in 2011, Hortonworks was spun out of Yahoo, because Yahoo was at the time the largest internal user of Hadoop. So that's how it all started. I wanted to start with the basics because you'll see we have come so far in the world of big data analytics at scale since these early humble days, but it really was something, it was a totally brand new technology, and it was solving a brand new set of problems that no one had ever tackled before. So on the next page, I have a picture of Doug Cutting. So he's an extremely tall guy. He was a rower at Stanford. He's probably like 6'6". He's holding that same stuffed animal on the left, and then that's a picture of me with Doug at one of our speaking events. But the origin story about Hadoop wouldn't be complete if I didn't describe that the name Hadoop was originally the name of Doug Cutting's son's stuffed elephant that he's holding there. And when his 2-year-old son started calling that animal Hadoop, Doug thought, you know, someday that's going to make a great name for an open source project. So that's the original animal, and there's a lot of lore about how that led to the naming conventions within the Hadoop ecosystem of naming all sorts of sub-projects after zoo animals. So now we enter the phase of the sudden rise of the Hadoop zoo. Anyone recognize the movie reference here? Seven Almighty, right? So what do I mean by the Hadoop zoo? By the way, Doreen, let me just pause and ask if there's any questions that have appeared so far.
No, there haven't been.
Okay, perfect, thank you.
Mm-hmm.
Either people are bored or we haven't gotten anything interesting.
I think everyone's just listening.
All right, so now suddenly Hadoop goes from a relatively manageable number of new components, the storage and the compute components, to suddenly this massive ecosystem where every month or every 2 months, innovations are being developed, oftentimes incubated in these large users like Facebook, LinkedIn, companies like that, and then released as a brand new open source project unto itself. So we always laughed about the Hadoop zoo, but literally there's Pig, there's Whir, there's Hive, there's Mahout, there's there's Impala, there's a whole bunch of these crazy open source projects, oftentimes with elephant themes, that were appearing with great regularity and being incorporated into this broader ecosystem. And this was really a reflection of the strength of the open source development model and the fact that there was this huge community of software developers all working on different aspects of this big data analytics problem and coming up with new ways and better ways to solve particular functions within the overall IT landscape. And so there was a super dynamic environment. And again, this is just a pictorial representation of it. But along with all of that extraordinary innovation, commercial challenges in particular were very, very persistent. So I just mentioned that the Hadoop ecosystem itself went from 3 Apache projects to over 30. And open source really within the commercial technology world became this new religion. And just like any religion, it inspired religious wars. There were fanatics on all different sides of this debate, that many of which were so adamantly supportive of the open source development model that they would, to use the phrase, they would cut off their nose to spite their face on a regular basis. And people made decisions on who they would collaborate with and how much information that they would share. And on when there were multiple ways to solve a particular problem, people would fight to the death, just like religious fanatics, over which way was more consistent with the ideals of the open source software movement. So it was really an interesting time to see how strongly held beliefs would get in the way of pragmatic and commercial decisions just because of the religion of open source. And then on the customer side, most importantly, I think the big data industry trained customers to expect the equivalent in enterprise software of a free lunch. They all expected that because of open source, there was faster innovation than any proprietary software company could handle. And that actually was true, but customers also expected the same level of quality and reliability from this open source development model that they were used to from the Oracles and the SAPs and the IBMs of the world, which just by virtue of how open source is developed and tested is an unrealistic expectation. But nonetheless, people trained customers to believe this. They also expected all of the enterprise functionality that they were used to in these proprietary solutions. They expected that that should be also present in the open source world. And the reality is, management and administration is not the most exciting technology problem to solve. And so software developers really were not as interested in trying to make software more usable. They wanted to push the boundaries of analytic technologies. Because it was called open source and because it was supposed to be free, they didn't want any sort of lock-in from any vendor. They wanted complete transportability between, for example, Cloudera's version of Hadoop and Hortonworks' version of Hadoop and MapR's version of Hadoop. And because it was all open source being developed out in the open, everybody expected it to be free. So it was this extraordinary expectation or set of expectations that, not surprisingly, were almost impossible to satisfy. All right, any questions so far?
We do have one question in the chat. Curious to know how the open source software was monetized. How did Hadoop generate cash flow?
Perfect lead into this slide here.
Oh, perfect. Okay.
Here we go. So again, these are the three main competitors. You'll see that there were others, but here's the difference right here, right? On the spectrum of open sourciness, as we used to joke, Hortonworks had their company ethos as we will be 100% open source forever. We will never charge software license fees. We will actually never have any proprietary intellectual property. The Hortonworks business model was purely, we will give away the software and we will charge for support and professional services on it. But there was no software licensing. And this is really in response to, a lot of it's in response to the commercial practices of Oracle and other software vendors at the time, other database vendors. Nobody liked the process of dealing with those commercial vendors and feeling that they had you over a barrel because you were locked into using their database, for example, once you embedded it in an application. So that was Hortonworks' business model, and they were most committed to open source. At the other end of the spectrum was MapR, where they had a proprietary file system. So the file system is where your data is stored. And so if that in and of itself is proprietary, then that's, then that is not transportable to other vendors. And so if you bought MapR's version of Hadoop, you paid them a license fee no matter what. There was no free version of their software. And then they also charged for technical support. Technical support was part of their software, but they also charged for professional services. Cloudera had this middle ground where the commercial model that we evolved to is actually the commercial model that today is the most prevalent. And it's this hybrid model where there was an open source core, which means that Cloudera's distribution of Hadoop included what we would call a free or 100% version that required no license fee. It also didn't come with support, but you could have that version of the software and you could deploy it and you could never pay Cloudera a dime if you never needed any support on it. However, if you wanted enterprise grade functionality for the administration, for the maintenance, for some of the other kind of more advanced capabilities, Cloudera then created a richer enterprise offering, which did require customers to pay a subscription fee for a software license. So that's why I put Cloudera in the middle of this spectrum. And to answer the question specifically, Cloudera's model of hybrid open source core with proprietary enterprise add-ons, that's what's evolved into the standard commercial model for open source today. So hopefully I answered the question. So as a result of all of this, there were two basic approaches to big data and analytics at scale that emerged. Number one were the pure play Hadoop distros. Again, we've talked about Cloudera, Hortonworks, and MapR, but also IBM had their distribution, and they didn't succeed in the market, they failed. Intel had their own distribution. At the beginning of the cloud days, Amazon had a version of Hadoop that we'll talk about a little bit later in the cloud section. And then all of the traditional, what this screen calls the big boys of data management, that had database-like or data warehouse-like technologies for doing analytics, they were quickly evolving their solutions to be able to scale up to larger and larger data volumes. Now, these solutions, the big boys of data management, were challenged because they could only handle structured data. So that notion of tabular data, database tables of columns and data stored in rows, that was one part of the big data world. And these solutions, like the Teradata Data Warehouse or the Oracle database, those were able to and even mainframes for that matter, were able to analyze bigger and bigger data sets, but it was still structured data, okay? The challenge, though, is that every one of those solution players, whether it was the Hadoop distros or the big boys, they're all competing for the same workloads and the same use cases, all right? We've all heard the phrase, not my first rodeo. This happens to be, what is this called? This is called the CAF. It's an event that happens at all rodeos where a bunch of contestants just run around, and these are all 4-H high school students trying to capture the calves and stuff like that. This is literally what the early days of Hadoop reminded me of. And it was a rodeo. So as the world of big data evolved, and it evolved very, very quickly, we started to see these really unusual alliances forming, like the three axes, if you will, of big data. So you can see Hortonworks early on formed strategic partnerships with companies like Teradata and Microsoft and SAP and EMC. So those were their chosen partners. Cloudera, interestingly enough, partnered early on with Oracle. And then later we took a pretty sizable investment from Intel. And at the same time that they made that investment, that equity investment in Cloudera, they got rid of their Intel distribution of Hadoop and became essentially all of their customers they encouraged to shift to Cloudera's distribution. So you can imagine that we went from this very competitive environment to suddenly these alliances being formed of very unusual and in some cases quite strange bedfellows. The lessons, well, actually, let me get to the next slide first. Over time, as happens in the business world, the alliances formed and shifted as different companies had different momentums and were starting to evolve their partnering strategies. So you see the difference between this slide and this slide. Both Microsoft and Teradata went from being exclusive partners of Hortonworks to then playing equally well, or in some cases, we think, from the Cloudera perspective, biasing their later partnering and go-to-market activities in partnership with Cloudera. We also announced a partnership with a division of EMC called, as you can see on the screen, DSSD, that shifted the EMC allegiance in their field from going to market with our competitor Hortonworks to now going to market kind of with a first bias towards Cloudera. It was a fascinating time to be in business development. And by business development, I mean the alliances, the channel partnerships, the strategic partnerships part of a software company. I personally managed the Oracle relationship with Cloudera. And when we first formed that, everybody in the industry expected that Oracle was going to buy Cloudera someday. And of course, I didn't do much to try and disavow that rumor, because that helped us, because Oracle was our big brother. But again, we were all competing for the best partnerships that would be able to generate the most momentum in the market, while at the same time playing a very interesting game of having multiple partners. You know, I always called it the multiple boyfriend or multiple girlfriend strategy, where you want every one of your partners to believe that you are, you know, primarily focused on your partnership with them, but in fact, you're also working with their direct competitors in a similar type of a partnership. So it was a fascinating time to be on the business development side. Doreen, it looks like there might be a couple questions coming in. Are there?
Yes, there are. So the first one was, how did Hadoop work with public cloud providers back in 2007, 2008? Did you need to work with a Hadoop distributor in addition to your public cloud provider for your big data needs? And then the other question is, why do you think Oracle made the decision to not to purchase Cloudera?
So let me address the cloud one in a couple of slides, because I'm going to go to a whole section on the cloud. Excuse me. And as to why Oracle never bought Cloudera, Cloudera was one of the early unicorns. And so especially once we took on the investment from Intel, our private market valuation was well in excess of, you know, $3-4 billion. And the belief was that Larry Ellison was just never going to spend that much money on a company whose software was open source. So we heard, I heard plenty of rumors of internal conversations at senior levels within Oracle where that perspective was repeated. But we were also, the partnership was working well for both companies. And we were essentially an OEM software component on some Oracle hardware called the Big Data Appliance. And that actually was a way that Oracle was able to get into the big data game and be able to provide a solution that analyzed both structured database data and unstructured Hadoop data. And they were also a very strong distribution channel for us. So as a partnership, even though there was natural friction and tension, it worked quite well. But I think really the main answer for why Oracle never bought Cloudera was it was an issue of cost, and our market valuation after the Intel investment was just too high for them to consider. Any other questions, Dorina?
No, there's no other questions right now.
Perfect. All right. So now let's talk about the cloud, because while this was all going on, the cloud went from this, you know, little known business that AWS started because they had some extra compute and storage capacity in their Amazon.com data centers and figured out through the magic of virtualization how to resell that to other companies. It went from an oddity to what we now know today is it's the default way of running your business, running the IT part of your business. But because of where Hadoop started, it was hard to conceive in the early days. In fact, the early proponents of the cloud, actually, the early proponents of Hadoop looked at the cloud and said, yeah, that'll never amount to anything. And Data, big data, the scale of which we were talking about in the early days of Hadoop was just way too expensive to move and then store in the cloud in the early days. And so all the Hadoop vendors really looked at big data as a very much in the data center and on-premise problem because of the gravity of the data itself. And it just in the early days didn't make sense to move that from your server farms in data centers where all the data was being generated. It just didn't make sense to take it and make a copy of it in this much more expensive platform called the cloud. And the ability to do analytics on the cloud in the beginning were obviously not very mature either. So before any of the analytics capabilities caught up to what Hadoop could do in a data center world, nobody looked at the cloud as the logical place where someday big data would be stored. But we were wrong, or rather we just weren't looking far enough ahead, because the cloud did a couple of had some impacts that now as we look back it should have been obvious, but it wasn't obvious at the time. So from a technology and a complexity standpoint, the cloud was always perceived and presented to customers as, well, this is the easy button. Remember all those servers that you had to procure. Remember all those software components that you had to install yourself, and then you had to upgrade yourself on all of those servers. Why don't you just get started in the cloud, and here, we'll take care of all that. All you have to do is put your data in the cloud, and then you can start analyzing it. And that really was ultimately the biggest problem that customers of big data and Hadoop solutions just couldn't solve on their own. Hadoop was very complex, and although it was powerful and solved new problems and delivered new insights that had never before been possible, it did it in a way that was really complicated. So the cloud made all of that much easier than it had ever been. And at the same time, it lowered the business risk of starting new IT and especially new big data problems. It lowered that business risk substantially. So this is the proverbial photo. This is John Lithgow from Third Rock from the Sun, but I found this photo when I was searching on belt and suspenders, right? Because the whole duplication of risk mitigation strategies, everyone laughs that you're not supposed to wear both belt and suspenders. The cloud really reduced the risk of new projects, which up until this point in the IT world had a reputation well earned for not being successful. So there were many, many stories in the big data and Hadoop industry of customers that had gone down the path of Hadoop and for one reason or another had not seen the return on investment because the projects failed due to technical risk or business risk or things like that. And the cloud really went a long way towards solving that risk. And then the final element here, in the beginning, the cloud was actually very expensive. It was an expensive place to store large volumes of data. And it was an expensive place to rent the computing power that you needed to do even the most basic of large-scale analytics. But cloud providers did a really good job of continuing to drive cost out of their business and putting pressure on the entire rest of the ecosystem to scale out their offerings and to drive down pricing, which, by the way, they also introduced new pricing models. It was very, very transparent. And so it was very easy to compare your cost of doing business in the cloud to your cost of doing business in your own data center. And over time, the cloud became a place where, especially for getting started, you could do it at a much lower cost structure. So the cost savings from the cloud started to become apparent, and they accelerated over time as companies got from just starting new projects in the cloud to getting out of data centers entirely. So let's go a little deeper on this, but I mentioned a couple of these concepts just now. As we said, the cloud simplified big data technology, and the cloud providers themselves made it much simpler for companies to adopt big data in the cloud. So I talked about the economics of virtualization at scale. As they built out their data centers and built out their capacity, they lowered prices very aggressively, and the economics soon became a wash, even for large implementations of big data. At the same time, as they were moving from just being a provider of infrastructure, and by that I mean just storing data and renting CPUs or renting processors, Amazon, Azure, and Google Cloud all developed in-house proprietary analytics offerings. So we'll talk about that in a slide or two. But what they did, in essence, was to take the open source components of Hadoop that were being used for analyzing these different sources of data. And the industry vocabulary that developed was they were strip mining the open source by taking the code, building a proprietary version of the same analytics that were available in the open source world, and then offering it back to customers as a managed service. And whenever innovations happen in the open source world, they would just look at the open source itself and take that code and add it into their proprietary offerings. So that was a source, and it still today is a big source of conflict between advocates of the cloud providers and the open source community, where still a tremendous amount of the innovation and development happens. I mentioned managed services. The idea that you can go from buying or renting all the components of an analytics environment and then assembling them yourself, so you needed a lot of internal skills to do that. Then this model of managed service solutions evolved, where the cloud providers suddenly offered a pre-integrated, pre-bundled set of capabilities. They managed all the complexity and risk for you. You just used their managed service solution, and you got to focus on solving the business problem that you and your internal users were asking you to solve. So it removed a lot of the challenge of the 80% setup and preparation time, and just let you focus on the value add of doing the analytics for your users. I mentioned that the cloud commercial model was one of usage-based pricing and also transparency. So today you go look out on Amazon's or Microsoft's or Google's websites, and you can see very clearly how much they will charge you on a per hour or a per minute basis for every piece of technology in the analytics stack that you think you'll need to run the analytics that you need to run. So that whole transparency and that by the drip usage-based pricing was very new, and the cloud is the cloud is what made that possible. So in addition to all the technology and commercial things going on, you started to see in the last couple of years this C-level discussion, this pressure of companies at companies of all sizes to simply get out of the data center business entirely and to run all of their infrastructure on Amazon AWS or on Microsoft Azure. Again, that didn't start happening until the economics of the cloud made it compelling, but the cloud providers were talking a very good game early on, even before, in my opinion, the economics supported this move. And as a result, there started to be tailwinds for the cloud providers around just board level discussions of what's it going to take to become more agile, to get out of the data center business and to just worry about the kind of the highest level, the highest layer in the analytics stack, which is solving business problems. So that was that and still is today a huge tailwind for the cloud providers and a headwind for any of the independent Hadoop distributions when it's just a broader business trend. So as a result, I summarize this by saying that the cloud vendors were just playing a different game. They were having C-level discussions, not about big data analytics, but about cost structures of the entire IT function that no one set of software vendors, including the Hadoop vendors themselves, could play in, right? We could argue that we had a cost advantage when it came to specific analytics, but cloud vendors were solving a much bigger and much more impactful business problem when they were talking about the overall cost structure of the data center. So let me pause. A lot of big topics here. I'm sure there's going to be some questions. Dorina, you got any?
Actually, there aren't any questions right now.
That surprises me. Come on, these are the topics that I think are the most interesting here. But anyway, I'll keep going and we can come back to them, right?
Okay.
So said another way, I put these two quotes in here just to illustrate the magnitudes of the shift to the cloud. So this
Excuse
first
me,
was
I think there's some questions on the chat, Zoom group chat.
all right. Can I ask somebody to read them or
What was your question that I missed?
The questions are on the Zoom chat.
Yeah, which question what was your question that I missed?
It's not me, but somebody else asked, why do you think Oracle made the decision not to purchase Cloudera?
Oh, I asked that, yeah.
Oh yeah, we covered that before.
Okay, cool.
And by the way, when Oracle came out with their cloud offering for Hadoop, they didn't use Cloudera's distribution. They used a free open source version of Hortonworks. So even they didn't want to be dependent on paying a commercial subscription for software that was free when they came out with their managed service version of Hadoop. So the same trends played out. All right, so anyway, I'm gonna mention these for the recording, the two quotes, but a customer of managed service Hadoop said, Hadoop deployed in the public cloud allows us to make decisions solely based on internal customer needs and not what our infrastructure can support. Really important concept there, because previously, before the cloud and before managed service, a lot of times companies were not able to answer or to analyze the kinds of questions that they wanted to analyze because they just didn't have the right infrastructure in place in their data center. And the cloud eliminated that issue for them. And this second quote here was also representative of what we've already been talking about. Quote from an industry analyst was, the public cloud nailed operational complexity challenges. This was a major blow to the Hadoop distribution companies like Cloudera, Hortonworks, and MapR that were too late to the cloud. AWS, Azure, and Google Cloud Platform nearly eliminate the operational complexity of operating the core components of the Hadoop ecosystem. So now that brings us to the discussion of analytics at scale today. And this again was probably the most fun for me to go and poll my network on their opinions of kind of what did we learn from the experiences that I just described. So these are collections of conclusions and lessons learned that are at the heart of it opinions, but hopefully this will ring true with a lot of the experience that you folks have from either your pre-Anderson UCLA experience or from your experiences as you're contemplating where you'll work after UCLA. But here's what analytics at scale looks like today. The big three public cloud providers, and again, Amazon AWS, Microsoft Azure, and Google GCP, they all offer end-to-end analytics platforms. Every single one of them has a very rich set of offerings. I think Amazon's in the analytics space is 150 or so discrete components, all of which are offered as a managed service. Many of them have at their heart proprietary versions of the open source projects that include the Hadoop Zoo. But what you'll see is that they all have different approaches when it comes to partnering with other solution providers and even other competitors in the ecosystem. So I'll speak about that in a subsequent slide. From the Hadoop's perspective, the Hadoop industry perspective, probably know that 2 or 3 years ago, Cloudera and Hortonworks merged. So now they combined their Hadoop distributions, and today they offer that combined solution still as an on-premise solution, but also as a public or a private cloud solution, and of course as a managed service. Let's see, the epilogue on MapR is that MapR failed as an ongoing business, and their assets were sold in 2019 to HPE, to Hewlett Packard's enterprise division. And the rumor has it that that was sold for well under 50 million, which is a fraction of the $280 million that MapR raised. And of course, today there's an incredibly strong ecosystem of many best-of-breed solutions as well. You have open source companies like Elastic, which is the open source company that has a distribution, if you will, of Apache's Elasticsearch. Confluent is the one company, the commercial entity that supports and drives development of Apache Kafka. And then Databricks is similarly the commercial entity behind Apache Spark. And then you also have plenty of proprietary software vendors that are BI tools, that are DevOps tools, that are providers of artificial intelligence and machine learning solutions. So I wanted to give a picture or two example of what the analytics at scale looks like today. So I just—
Sorry, we do have one question. I don't know if I should ask
okay,
it.
go ahead.
Okay. Wait, sorry, I'm trying to look. Okay. Why would you say that Hadoop distros didn't actually jump on a business opportunity after they saw cloud providers becoming this successful? It seems that they were very well positioned for an development attack. For example, why didn't Horton set up a cloud?
Hey, Doreen, I apologize for interrupting.
Yeah.
It's hard to hear you. I think you moved away from the microphone. Could you repeat the entire question, please?
Sure, sorry about that. Can you hear me better now?
Much better.
Okay. Why would you say that Hadoop distros didn't act to jump on the business opportunity after they saw cloud providers becoming this successful? It seems that they were very well positioned for an development attack. For example, why didn't Horton set up a cloud themselves and have their customers transition to it?
So great question. And the answer is they actually did. All of the distributions moved as quickly as they could, I think, to providing their solutions on the cloud. But they weren't, none of us were as agile as we needed to be to compete effectively with the emerging cloud offerings from the big three cloud providers. So by the time that the trends were unmistakable, I think all the Hadoop distribution companies were moving as fast as they could, but just the legacy of and the complexity of their 30 plus component platforms was very hard to move all at once to the cloud, whereas the cloud providers were able to start and create these new analytics offerings one by one on top of their storage framework. So here you've got a picture here of the Microsoft Azure. I just borrowed this schematic from their website. Couple of points I want to point here that point out that'll make the answer to that question more clear. First of all, you can see every single one of these solutions, these atomic components here, is called Azure something or other, right? Azure Data Factory, Azure Data Lake Storage, Azure Databricks, Azure Synapse. That's just an indication of all of the different, what you could call kind of best of breed competing point solutions for a specific function within this overall analytics workflow. But the cloud providers were able to develop and release those capabilities to the market, first of all, very fast, because they were developing it on their own cloud, which is an agile platform. But second of all, they could do those one by one, whereas the Hadoop vendors had built these platform solutions that had 30 components, and you couldn't really just release one of those components for the cloud at a time. So the effort and complexity of the move of the Hadoop distributions to get to their cloud solution and their managed platform, managed service, also impeded their ability to pivot quickly as the cloud gained momentum. Did I answer the question?
Yeah, thank you.
Okay. Any other questions, Dorina?
I have a question.
Sure. Go ahead.
Do you think it was also because there is in cloud, there's the whole aspect of this infrastructure piece and everything where the big three had so much of leverage in terms of pulling together infrastructure and hardware and data center, which takes a time to build, which these cloud providers could never do. So these big data providers could never do.
So yes, that's correct. Um, they started at scale, and scale makes a lot of things easier, right? But I mean, the cloud providers, they didn't invent virtualization,
Mm.
but they were the ones that took virtualization to its logical conclusion. And as a result, they were super nimble and agile at everything they did. And then don't forget that the Hadoop open source movement gave them the head start by just making the open source code and solutions freely available so that they could begin with this practice of strip mining, right? Now, IBM was long accused of doing that as well. It used to be in the early days of Hadoop, people would, Cloudera and Hortonworks and other companies would compete over who had more committers to each of the Hadoop Zoo projects, right? We would say we have more committers to Spark than Databricks or Amazon did, or whatever was the argument. But IBM always had the reputation of, they made announcements about open source, but the reality is all they did was pull from the open source community. They never committed back to the open source community. And so it was all take and no give, if you will. That same observation and disparagement many people still make about all of the three cloud providers.
Yeah, I agree.
Okay.
Makes sense. Thank you.
There's one more question just came in.
Go ahead.
Does the size and scale of the big three public cloud providers impede them at all? And does that offer opportunities for others to compete in some part of the cloud ecosystem?
Well, I'm not sure that there's any natural impediment. I mean, the history of business is as companies grow too big, they cease to be as agile. And you can make a theoretical argument about that with the big three, but I don't think it's playing out yet. Does anyone have any different opinions on that? That this is a point for discussion, and I'm just offering one opinion.
I second that, and in multiple courses in our program, we'll speak about the innovator's dilemma, as in once you get to the point where you're too big, making that shift is very difficult, and that's why you end up not reacting to something that's disrupting you. Same thing that happened, for example, with Hadoop. They're already too committed, and to them it was like sort of a step down in terms of technology before it ramped up to get all those analytics features to the point where it wasn't feasible for them to transition to it.
Mm-hmm. One of my colleagues at one of the big three cloud providers that I spoke to this past week said that they still, when they're providing all the infrastructure to the web scale companies like the Pinterests and the Facebooks and the LinkedIns of the world, they are still competing with open source from the standpoint of those web scale companies need to have active open source, not like really, really active open source capabilities internally. And they need to be constantly spinning out new technologies, whether they're successful or not, into the open source Apache world, because that has become their main recruiting tool. So, LinkedIn relies on the fact that that their engineers are innovators and are committing stuff that has incubated within LinkedIn back into the open source world, because that's what makes other engineers want to work there. So, today, and that same thing I think applies to the big three cloud providers. I heard from multiple friends that they even if they do, and I'm not saying anyone would admit to this, that they would do this whole notion of strip mining, but they are maintaining, they are big sponsors of the Apache Foundation. They're sponsors of the open source conferences, and they have a lot to gain by being perceived as very friendly to the open source environment, because that's the kind of stuff that the best engineers in the world really want to work on. So I don't think that they have any sort of a disadvantage as they've grown, because they've remained agile, and they also remain very active in their own ways in the open source world. It's self-serving, but they're still quite active participants, right?
Do you think the same will happen to R?
The same meaning, do I think that that the big three will have proprietary versions of R?
Yes. Or somebody else, not necessarily the big three, but to be disrupted with something else that strip mines their technology the same way the big three sort of, if they wouldn't admit it, but still in a sense did strip mine Hadoop's open source technology.
So I think yes. I mean, everybody has access to R libraries, and everybody's going to be taking those and embedding the kind of the open source algorithms, if you will, in their own proprietary code. So I think yes, absolutely. And plus, probably the bigger threat for that is, you know, a company like SAS, which is a very large, still pure play or perceived as pure play analytics company. So I think that yes, that's probably already happening now. I just don't have any kind of personal experience with someone telling me about it, but I'm sure I could find one. All right, are there any other questions? All right, and if not, then, you know, hold them as you think about them, because just got a couple more slides here. But one of the other things I wanted to make out, and I just chose Microsoft, but if I had chosen a schematic from AWS or a schematic from Google Cloud Platform, you'd see the same thing. So number one is, you can see all of these solutions are called Azure this, Azure that, Azure the other thing, and even Power BI is a Microsoft BI tool, right? So this is an all Microsoft stack. And I highlighted this Azure Databricks, because remember, Databricks is the company that is the commercial entity around something called Apache Spark. Apache Spark was, when it was developed out of Berkeley, it was called the replacement analytics framework to the original MapReduce. So there's a long, you know, lineage here. Microsoft will talk about their Azure Databricks solution, and I know, and there's a full sales force within Databricks that is dedicated to the Azure partnership. I have several friends that are part of that sales organization. At the same time, you look at the Databricks website, and Databricks will talk about how they partner with both Azure and AWS. And so AWS will also have places where they use and partner with Databricks. So you can still see that depending on whose lens you're looking through, if you're one of the big cloud providers, you'll say, we can solve your end-to-end analytics problems and challenges with all of our in-house products. And we also partner, so if you want to run someone else's software on our compute and storage platform, you can do that. And then all of the different partner solutions, Databricks is just one of many examples. We'll talk about them and their advantage over the in-house solutions from any one cloud vendor, as their advantages, they are multi or hybrid cloud, right? And they run equally well on AWS or on Azure or on Google Cloud Platform. So everyone's playing this different game of trying to be the best at what they do and build an ecosystem of partnerships with them at the center. The other thing I wanted to highlight on this particular screen is something that we'll talk about in the lessons and learnings. But see up at the right-hand corner, it says try Databricks, and it's a little button that I've circled in red. Every single solution provider nowadays has done a version of this, which is they've made it as easy as possible for developers, because developers are typically their first initial customers. So they made it easy for developers to just try their solution, right? And they'll free up, you just click on that, and in like 3 minutes, you'll have a free play environment on either AWS or Azure to try to try using Databricks' version of their solutions, right? So the cloud has removed all friction from just getting started and just trying something out. And the idea is, you know what, let's just get them using our software. And then at some point, either it's a free trial that runs out, but they've already made the investment and they've kind of proved to that they've sold to themselves by proving that the software works for their particular small application, or lots of people are using it within the company for free. And at some point, the solution provider themselves will say to their IT organization or to their procurement organization, look, you've got 100 different small projects, and each one of those small projects is on our software on the free version, and you're doing without any of the enterprise grade functionality that we offer. We'd like to make you a strategic proposal for the enterprise grade version that delivers functionality that every one of these 100 projects wants, but can't have right now. So the sales process, the sales motion has changed dramatically from where it was when big data first started, where it, was all about competing for free, but still, you had to start the sales process by evangelizing a new technology. Nowadays, the new technology gets evangelized within the developer community all on its own, and the sales function is all about coming in afterwards and working on creating a commercial proposal for software that's already in use. Questions on that?
Yes, there is a question that came in. It says, are there other industries or open source technologies to watch? Docker, Flutter, Atom, TensorFlow.
Yep. Yes to all, right? Every single one of those projects has commercial entities around it, right? I mean, I wasn't super familiar with the history of Docker, and I did a little bit of research preparing for this. And you know what? That's why the people that invented containerization, right? The guys at Docker have struggled to ever commercialize it, and they just Docker just sold their entire enterprise business, and which includes like 150 salespeople, to another company. It starts with an M, I can't even remember the name. And they've now gone back and kind of rededicated themselves to open source. So, everywhere in the open source world, there are companies trying to create a commercial model around open source software. And it still is hard, right? If you happen to create that new open source project that just it really solves it solves a technology problem in a very elegant and scalable manner, and you get that widespread adoption, then you know what? Yeah, you're going to be able to develop a commercial model around it. But there's a lot of open source projects that still exist because they're good technology, but no one has ever figured out a way to commercialize them. So this is where I would take this talk and turn it into literally a 6-week lecture, because there's so much interesting stuff going on in the technology world. There's also, hardware open source too. There's a lot of different forms of open source, and the challenge is always the commercial model around it. So that's actually where I'm going to end up on the next 2 or 3 slides. So with your permission, I'll jump to lessons and learnings, and we have just about 20 minutes to finish up. All right, Doreen, am I on track for the timing here?
Yeah, you're good. You're good.
Perfect. So indulge me here in a little bit of a build so that you don't read ahead. So again, collecting from a lot of different perspectives over the last couple of weeks, one of the themes from my friend's experience is just be pragmatic, right? Don't be so wrapped around religion or the software or open source version of religion that you forget what you're really trying to do is solve problems for people and build a commercial success. And a lot of people let their open source religious fanaticism get in the way of making very practical decisions that would have led to better alliances, as an example, that will increase the adoption of your product, but somehow, because you just can't find a way to bridge the ideological divide between yourself and a competitor, you would never form that alliance. The real lesson here is be pragmatic. The goal, of course, in any business is to become the standard as quickly as possible. So I've talked about how this whole experience in big data has shown that, companies have innovated around ways to get their solutions, their software adopted as broadly and quickly as possible. That challenge will never go away. And this is what everyone talks about when they talk about building for scale and scaling as quickly as possible. Because your goal is to become the standard. Why? Because that makes it less risky for your customers, right? Your customers don't view it as risky to invest in your technology if everyone else is using it also. So we've talked about all the ways that companies learn to make it really easy for your prospects to become your customers and for your customers to expand their use of your software. And again, we had a couple of examples of that. This is a really important point here. We didn't talk as much about the commercial model that evolved. When I described it as, Cloudera had this hybrid model where we had an open source core that was free to download, and then we charged for enterprise grade functionality and required a subscription for that. That is probably the most common model today in software, because everyone gives stuff away, whether it's just a trial or whether you actually have a free scaled down version of your product. This is probably the most important decision you'll make. What is it that you're going to give away? And what is it that you're going to charge for? If you go back to the early days of the first open source software, Linux, right? The operating system that was an open source version of proprietary Unix. I learned in my preparation here that Linux was always open source, meaning you could look at the software and see all the code. But Red Hat, one of the original and the first company to make a scalable success out of open source, their decision was to withhold what's called the compiled image of the source code. So you could have the source code for free, but the compiled image is what really delivered the consistent, reliable operating systems experience, and that's what they charged for. Lots of companies have come up with different things that they withhold, and striking that balance between giving away enough that you become the standard quickly, but holding back enough that you have a successful commercial business. This is the hardest problem to solve. And patterns have emerged, but there still is room for individual innovation. So along with that decision, how you structure your commercial model and how you license your IP matters tremendously. I have been, as a sales guy, I'm pretty strong with contracts, and I insist that all of my sales team be really good with contracts, because contracts matter. They matter so much. You've seen in the last few years different companies like MongoDB and Confluent and Couchbase, I think, is another, and Elastic, which is the company behind Elasticsearch. They've all tried to come up with new versions of open source licenses that prevent the cloud providers like AWS from coming along, taking their open source free version and then creating a proprietary managed service version. So, these are all challenges that the open source community struggles with. But it's really important because you got to find the way to decide how you're going to protect your IP. And oftentimes that comes down to licensing models. Okay. I talked about the importance of ecosystems. You got to pick the right strategic partners, and then you have to invest in the relationships, because this was my area of responsibility for the first 3 years that I was in Cloudera, and I managed, the global Oracle partnership, and I was the one that, did the EMC partnership that I referenced there. And I even managed our partnership with IBM for a while. Partners, I won't say that they'll make or break your company, but they will absolutely affect that point number 2, which is how quickly you can become the standard and get the broadest adoption in the shortest amount of time. Go-to-market partnerships are very hard to build successfully, but they are super important. So don't, and again, there are stories in the open source world of companies not partnering with, quote, strange bedfellows because, you know, they didn't think that it made ideological sense. But the reality is those, you can look back historically and say, yeah, that was a mistake that we didn't partner with company XYZ, because they would have, their sales organization alone would have given us so much more reach and so much more mind share with customers than we ever could have gotten on our own. As you lead one revolution, beware of the revolution that follows. One of my friends who is in product management shared this as a way of summarizing all the amazing things that we did to solve these big data problems that technically could never be solved before. But we didn't realize that the cloud was coming along right behind us and it was going to change everything that we did. So just beware of the revolution that follows. And of course, the cloud will continue to change everything. Any questions on these? I got 1 or 2 more slides, actually 2 more slides, and then we can come back for questions. All right, so what do you do today? About building a viable software startup. Most importantly, solve a specific business need, because businesses built around solving a technical need will face more challenges, especially from some of the competitive dynamics that we talked about in the cloud industry. And you know, these kind of sound obvious, but I hope that they will at least jog your thinking to really consider it. Architect your business for simplicity, speed, and scale. That the fact that Hadoop was so complex in the beginning, and in order to solve the problem the way we solved it, our solution was not elegant. It was exciting, but it wasn't simple and it wasn't elegant. And it, as a result, made it hard to scale. Talked about whatever it is, if you're going to go into a technology, if you're going to go into any business, this applies, right? Just become the standard and do it as quickly as possible, and pay careful attention to removing friction and barriers to adoption in your customer base wherever you can, whether they're commercial barriers, technical barriers, cultural barriers sometimes, right? Make your company the best part of your customer's day. Dealing with you should be a pleasure. It should not be something that they dread, because that will be in and of itself a cultural barrier to them adopting more of your technology. It's obvious you gotta get product market fit early on, and if you don't, you gotta be agile. This hopefully is obvious to everybody by now, but the cloud is the default technology platform for your customers, certainly, and it should be for you as a software startup too, right? Unless you're solving a super specific corner case problem that occurs only in on-premise in the data center architectures, and those still do exist, right? But fewer and fewer of them. Your default should be develop and deploy on the cloud, because that's what your customers are going to expect. And then finally, here's some commercial considerations. Doreen, are there any questions before I get to this? I think this is my last slide.
No, there's not.
Okay, good. So, so many people, and frankly, so much about your business school experience is about product and product strategy. But from the very beginning, even if you are or work for a team of technical founders, you got to be thinking about the commercials from the very beginning. And so these are the lessons, at least the lessons from my experience over the last 10 years. So we've talked about the evolution of open source business models. I think today the business model is largely decided on. Everybody is doing subscriptions and focusing on annual recurring revenue, because that gives you the highest multiple when you go out and raise funds and when you go to the public markets for an IPO. It is all about annual recurring revenue. Now, it's funny, there still are plenty of companies that haven't made the transition to this subscription-based business model. I worked for one of them last year, the robotics company. We had to move, and I was part of driving hard this business model to move it from a hardware-based, this is the cost of our hardware and this is then what we turn around and charge margin on top of, to no, everything's about a subscription. Everybody wants to shift their spending from what's called CapEx or capital expenditure budgets to OpEx or operating budgets, and this is how you do it. So your business model should be subscription-based. We talked about free trials and freemium offerings, right? Or the free core charge for enterprise grade models that we pioneered at Cloudera. And then these free trials. This is all about removing those barriers for your customers to adopt your product. So figure out how you can give a form of free trials and some form of a freemium offering if possible, because this will speed adoption. And of course, the value of managed services is to reduce that complexity and technical risk for your customers. What you're doing is you're shifting the complexity and risk to you and your business, but you're better able to manage that on your own solution than your customers can. So when you're figuring out a go-to-market model, you're going to have to figure out whether you're going to develop direct sales capability, whether you're going to be partner-led in your sales efforts, whether you're going to have a channel that includes companies that can resell your product, and you're going to then be sacrificing margin in return for getting broader reach to a wider range of potential customers. Chances are you're going to develop a hybrid model with some elements of all of this. But be very intentional in understanding how you design a sales model and a sales process that mirrors your customer's buying process. That's actually one of my personal learnings, in my career, which is in sales, you gotta mimic the buying process. You have to understand the buying journey that your customer is going through, and then align your sales journey to satisfy their buying journey. Okay? Then there's a whole bunch of new marketing technology solutions, MarTech as we call them, for specifically demand generation and the early stage educating of the market. A lot of people now call this account-based marketing or account-based sales development, but that has to be a part. You have to design that into your sales and go-to-market motions from the very beginning, because that is also one of the keys to this notion of scaling fast and removing barriers to to customers adopting your product. Was there a question that just popped up?
Yes, there is. 1 second. Can you talk about what has changed from a sales point of view and running a sales organization in this space? What are some of the big takeaways?
Okay, let me just hang on. I'm going to validate that this is my last slide. Let me get to one more point, and then I'll come back to that question. Okay. So, finally, the ecosystem dimension. Again, I've talked about how important those partnerships were, because this was a learning in my own career. Up until my time with Cloudera, I had been in direct sales. And then for very personal reasons, I couldn't manage a sales team at that point in my life. So I joined Cloudera in their business development team, and I managed, again, some of these global strategic partnerships. And that helped me to understand in a way that I never would have understood if I were just in direct sales. That helped me to understand how important partnerships and structuring partnerships effectively can be towards long-term success, right? So pay very close attention to which companies can help you to become the standard as quickly as possible, and then form strategic distribution or go-to-market partnerships with them. You're looking as a startup for who's going to be the best big brother for you, right? Who's the company that's going to propel you to adoption at scale? And like I say, don't be super pragmatic about that choice. Do not let things like religion get in the way of your picking the right business partner. Cloudera made some decisions that in hindsight weren't the best by ignoring partnering with companies that we thought were not committed to open source, and therefore we weren't going to partner with them. And it turns out in hindsight, we all thought that probably wasn't a very good decision. Then there's also a huge ecosystem of companies that may or may not be strong partners, but still you'll have to develop a partner program to create this broad ecosystem that also helps to propel you to becoming a standard. And of course, the goal in this broad ecosystem is to put your own company, right at the center of the ecosystem. So I didn't have an appreciation for the role of ecosystem until I had that responsibility myself at Cloudera. But now, that's a huge lesson that has been proven many times in our industry. All right, with that, that's my last slide. So now we can go back to the question that you had, Dorina, or that was asked. Can you repeat that, please?
Yeah. Can you talk about what has changed from a sales point of view and running a sales organization in this space? What are some of the big takeaways?
Yeah, happily, and there's many, so that'll be a whole nother topic for a longer lecture. But in a nutshell, the marketing technology stack that has emerged in the last 5 years, starting with companies like Marketo and HubSpot and things like that, and Yesware, and all these different solutions for doing outbound, very targeted marketing, which really is not marketing. I mean, it's demand gen, which frankly should live under the sales organization. But the technologies and the skills required to do effective outbound marketing and outbound lead gen is probably the biggest change that I've seen in the last 5-10 years when it comes to sales. And that doesn't have anything to do with open source or anything like that. That's just, new ways of not casting nets from a prospecting and demand gen perspective, but throwing spears, as I like to say. So there's a whole process for defining your ideal customer profile, right? Knowing what segments of your target markets are going to be the best places to focus on, defining very carefully what are the attributes, this ideal customer profile that you're going to go after, then going out and identifying all the target companies that match your ideal customer profile, and then going about defining all the personas within those target accounts that you need to be conducting outbound campaigns towards, and what are the messagings that you need to be writing for the different personas at those target accounts. There's a whole philosophy, there's a whole very well understood process for doing outbound marketing. And if you do it well, your sales team will be experiencing that embarrassment of riches, which is more demand that they can handle. If you do it poorly, your sales team will be yelling at marketing, where are our leads? And you'll have really, really good field sales professionals, very experienced and very good at the selling and kind of the negotiation part of the sales process, that are being forced to do some of the most inefficient forms of their own prospecting because the marketing and lead gen function is not doing the job that it needs to do. So I think that's probably the most important and the biggest change. There's also, I have my own philosophy on sales, which some of you may have heard when I presented to the Venture Accelerator cohort. There are a variety of other sales techniques as well, but I think that the most impactful changes have been in the demand gen and the account-based marketing areas. Any other questions?
Yeah, there's a couple more questions. I just want to say, anyone who has any more questions other than the last two that are in the chat, you can just wait a little bit and then say them out loud now that the workshop is over, but I'll read the last two.
Dorina, are you still there?
Yeah, can you not hear me? Can you hear me?
Looks like we lost her.
Oh, no, hello. Can you hear me now? Hello?
Figure out this myself. You guys can see me again, right?
Yeah.
Okay, perfect. Was that valuable? I mean, how many, still 46 people on. Wow, I'm surprised. Huh.
Yeah.
Can you hear me?
Was that
Can
helpful?
you hear me now?
Now we can hear you.
Oh,
Yeah.
sorry about that. Okay, I was just saying that there was two more questions and I was going to read them out loud, and if anybody had any more questions, just to say them out loud now that the session's over. But one of the questions is, how do these go-to-market considerations, sales and demand generation, change for a B2C company instead of a B2B company?
Fundamentally completely different. B2C is about casting nets, right? You don't market to an individual consumer. You market to demographics and to segments of the marketplace. Demand gen in a B2B world is so different nowadays because you are absolutely down to who is the director of procurement at company XYZ, which matches my ideal customer profile, and what's the sequence of emails that I'm going to define in my outbound campaign to get that man or woman to pick up the phone when I call them, because I just saw that a minute ago they read my email, because I have sophisticated email tracking software, and I know the minute that person picks up, reads my email, I get a notification on my screen that tells me that I'm top of mind in that person right now. So if I call them, they're going to answer the phone and they're going to be like, huh, what a coincidence. I was just reading your email. It's not a coincidence at all. It's completely not a coincidence. And you wouldn't do that in a B2C sense, would you? I mean, I'd be impressed if someone calls me as I'm thinking, God, I could really use a Diet Pepsi right now. And then suddenly a sales guy calls and says, hey, I'm selling Diet Pepsi. All right, next question, Dorina.
Okay, and the last question is, as more clients turn to a hybrid cloud solution, do you see clients using less in-house solutions for the three main providers and leveraging more open source solutions in their stack that has multi-cloud functionality, i.e. clients will have less reliance on GCP, AWS, and Azure for advanced analytics? It's a long question. Yeah.
Okay, I'm glad I could read that because that's a complex question.
Yeah.
It's a good one. I think that companies will start at the big cloud providers, AWS, Azure, those guys are not going to be the ones that innovate with, hey, we got a new analytics framework for analyzing geospatial data or streaming video data in motion, right? They're more of, it's kind of like remember the rap about Microsoft when, in the Microsoft versus Apple operating system days where Apple was the innovator and Microsoft just copied in Windows everything that the Apple operating system was able to do in a graphics perspective? You kind of got that same dynamic going here. So it's the smaller focused providers that will drive innovation. And in so driving innovation, they will also create awareness for and demand for their new bright, shiny object. And they'll demonstrate momentum. And so customers initially won't be able to find what what this new bright, shiny object is from the big three. They'll go with the call it a point solution, if you will, or the best of breed solution, who will be architecting for all three of those clouds. And then over time, the big guys will develop their version of that. And they will then start peeling away the bigger, more enterprise customers. You know what, they'll peel away the smaller customers too from those individual focused point solution or best of breed competitors. It becomes, a matter of ease of adoption versus if your use case is so dependent on some new innovative functionality, you're probably going to start with one of the best of breed providers. And then over time, as that particular use case becomes more common and more well understood, people will then probably just start with the in-house proprietary managed service offering from the cloud vendor themselves. Does that make sense? I see some people nodding their heads in agreement as I'm kind of thinking through this question. Does that make sense, or does anyone want to offer a different opinion?
Hi, Todd. This is Sudeep Mishra from EMBA 2021. I am part of actually my company's cloud team, and we just migrated to AWS from BlackRock. So I have a lot of experience where we actually went from our own proprietary analytical tools to Microsoft, to Azure,
Okay.
because one of the biggest thing is resiliency and standards, like you mentioned in your slides. The standards are important because we want to provide reliability to our customers. So enterprise friendly vendor like GCP, AWS, and Azure, they're a big win for us, as opposed to like going to a startup cloud service provider. But that being said, the cloud startup service providers, they're looking for more of a niche customers. Like, for example, like Google has Kubernetes, and Kubernetes is a big seller for us. And now AWS also has a variation of Kubernetes. Azure also has Kubernetes. But Rancher went ahead and built a smaller version of Kubernetes called K3S, which is targeted towards smaller companies, targeted towards startups. So depending on what the need of the company is, they're going to go towards a smaller vendor. Maybe smaller companies will go to a smaller vendor, but more and more enterprise companies are focused more on the big three.
Yeah, and so I think that another way of saying what you just said is that the big three in-house offerings will set that bar at good enough. And if their offering is good enough, then people will kind of take them as the path of least resistance. But if there's something unique about one of these more targeted offerings from a best of breed vendor that your developers or your analysts or whomever is kind of driving the use case views as a must-have, then obviously they're going to go with that smaller, more focused solution until the big guys are able to strip mine, if you will, all that functionality, and and that becomes the new standard of good enough for the big cloud vendor solutions. Is that fair?
Yeah, I absolutely agree with that.
Okay.
And I agree with that based on my experience, as well as we evaluated dozens of vendors and we finally picked our choice.
Right. Okay, good. All right. Look, I could go all night. This is my favorite topic in the world to talk about, but you guys many of you probably have families to deal with or at least dinner to cook. So, Dorina, I'll take my lead from you.
Yeah, if everyone is done asking questions, we can wrap the session up.
Any more questions, folks?
Yeah, can I ask one more question regarding the data migration problem? So I've spoken to people who work for Oracle and talking about their next gen solutions, and the way they described it, they didn't tell me this, but the way they described it, it seemed that data migration is going to be their biggest point of friction and barrier to adoption. So do you think that somewhere at some time in the future, there's going to be either a company or some sort of software or any cloud provider who's going to move to solve this data migration problem to the point where their product or a startup's product can work in harmony between all three, and then that becomes the standard?
That company's name is Confluent. Yes.
Oh, okay. All right.
right? And so Confluent, think of Confluent as the kind of open source killer next generation solution of a Tibco or a Web Methods, or kind of that they are already in the data movement space, and as they expand their platform, they'll be doing more and more of data transformations and things like that kind of all lumped together in the data migration space. Now, if you're coming at it from it's purely about data transformations and data migrations, there's other companies like that, but there are a lot of players in this data movement, data flow part of the infrastructure that that have the potential to solve bigger and bigger aspects of that particular problem. In addition, the Informaticas of the world are doing everything they can to retool their offerings, and to incorporate open source things. I mean, I watched that. I didn't manage the Informatica partnership, but I worked closely with the Informatica sales organizations when I was running the West sales teams for Cloudera. And they'll say that they've solved it as well, but again, it's proprietary largely, right? It's not necessarily open source. And there's a lot of legacy code in those applications that newer startups don't have to deal with and can solve the problem cleanly in the kind of the cloud infrastructure world. But I mean, Kafka was a project, Apache Kafka, that spun out of LinkedIn. And it was like there was 3 people that that spun out of LinkedIn to form Confluent. And then the 4th person was a friend of mine from Cloudera who told me one day in the cafeteria, yeah, I'm going to go join this company because they seem to have solved a data migration problem in a way that I'm really excited about. And I never heard. And then all of a sudden, nowadays, Confluent is a unicorn with a valuation, significant. And if you talk to the folks there, they see unlimited potential for their technology and their platform to solve a lot of these problems. Now, there's other companies that would say exactly the same thing, but I think that that's a very, the problems in that space are well understood, and the people competing for bigger and bigger real estate for the solutions in that area are already probably known. Okay?
Thank you.
You're welcome. All right, anyone else before we say goodnight? All right, well, with that then, I'll give you back the rest of your evening, but I certainly enjoyed the conversation. Thank you for the good questions. And you saw my contact information on that final slide, but Dorena can get any of you in touch with me as well if there's anything I can do on an individual level to help you guys with the decisions you're facing now or post-graduation. All right?
Thank you so much. Yeah,
Thank
we really
you.
appreciate it. Thank you.
You're very welcome. Thanks for sticking around. Talk to y'all soon.
Thank you.
Have a good night.
Thank you.
Thank you.